friends! Welcome to Coding Garden with CJ. Tonight's episode, Code Katas number 5. Well, we're gonna break things down, one step at a time. We're gonna solve these katas, you and I. We're gonna break things down, one step at a time. We're gonna solve these katas, you and I. Code Wars, Code Katas, Code Wars, Code Katas, Code Wars, Code Katas, yeah. Let's do this. Welcome to the stream. If you're watching live, please throw a message in the chat. This is the show where I solve code katas live in front of you. I have a GitHub repo for this. If you go to github.com/codinggarden/code-katas, all of the previous episodes are there, and I upload the code that I write at the end of every episode. If you're not familiar with Code Wars, it is a website where you can practice coding and learn how to solve problems in coding. They have various problems with various skill levels. I've picked a few out tonight. On the GitHub repo, there is an issues page, and if you want to suggest a kata for me to do, you can go into that suggestion issue and just add some links in here, and I'll try them out on the next episode. If you are watching live and you do have suggestions, go ahead and throw them in the chat, and I will give those a try as well. Potentially. Probably. I will. Yeah, I will. So suggest them. I have a few picked out, but if any are suggested, I would take priority over those. And the first one I'm going to do is a 7 Caillou, sum of 2 lowest positive integers. Then I will do another 7 Caillou, credit card mask. I've picked out a 6 Caillou, create phone number. And actually, I learned that I'm pronouncing that wrong. It's Q, not Caillou. Q. And then also a 6Q, equal sides of an array. And then a 5Q, palindrome chain length. And then a 4Q, Roman numerals encoder. So, these last few are going to be pretty tricky, but I'm excited. I'm prepared to do them. Let's start with a fairly simple one. The sum of the 2 lowest positive integers. So this wants us to create a function that returns the sum of the 2 lowest positive numbers given an array of minimum 4 integers. No floats or empty arrays will be passed. For example, when an array is passed like this, the output should be 7. And then because that's 5 plus 2, the 2 smallest numbers. And then in this example, the output would be this large number because it's 10 plus this number. So let's try it. Okay. Just get right into it. Okay, so one thing, well, really the problem that we're first solving is to find the 2 smallest numbers. So we need to find the 2 smallest numbers. There are a lot of different ways to do it. There's even a way to do it like built into JavaScript. For the most part, you have to do something a little bit special. But I'm going to do it manually first, and then I'll show how we might do it using a built-in way in JavaScript. So one way we can do this is we'll say look at the first 2 numbers in the array, and really we want two variables. So a place to store the smallest number, and then a place to store the second smallest number. And so we have those 2 variables, and we want to look at the first 2 numbers in the array and set the, we'll say compare, not look at. So compare the first 2 numbers in the array and set the smallest number variable and the second smallest number variable. So basically, we start off, and at the beginning of the array, we're going to take those two numbers and just assume that they are the 2 smallest ones. And then we're going to iterate over the array. So we'll iterate over numbers, and we're going to start at the second index, so the 3rd place in the array, because we've already looked at the first 2, and now we just want to compare those 2 with the rest of the values in the array. So iterate over numbers starting with the 3rd number. We'll compare with the smallest. If if, here we go, if the current number is smaller than the smallest number, then we want to set the smallest number to be the second smallest number, and set the current number to be the smallest number. Because basically, if we found out that it's even smaller than our first one, we know that we can just get rid of the second one that we're storing right now. So we basically take this new number, put it as the first lowest one, and then move that one up to be the second lowest one. Yeah, and then else, if the current number is smaller than the second smallest number, then we will set the second smallest number to the current number. Okay, and that should do it, because by the end, when we reach the end of the array, we've compared every number with our smallest numbers, and we should have the two smallest numbers. And the last thing we need to do is return the sum of the two smallest numbers. Okay, let's take this logic and turn it into code. So first thing is a place to store the smallest number. So we'll say let smallest equal, and actually we can, I guess we could initialize these as the first two in the array. I guess let's follow my logic that I said here. So we'll have let smallest, and then we'll have a variable for the second smallest. We cannot start a variable with a number, so I'll say second smallest. And then compare the first two numbers in the array, set the smallest number variable. So let's say if numbers at 0 is less than numbers at 1, then we'll set the smallest equal to the first number in the array. Else, we'll set the smallest equal to the second number in the array. And we can go ahead and set the second smallest as the other one. So numbers at 1, and then this would be second smallest is going to be numbers at 0. And this else statement will just work because if it wasn't less than, that means it's either equal to or greater than. And for the case where they're both equal, it doesn't matter which one is the smallest or the second smallest because they're both exactly the same. Okay, so we have now taken care of the first two numbers in the array. We know which of those two are the smallest. Now let's iterate over numbers starting with the third number. So I need a for loop. I'll say let I equal 2 because I want to start at the third number in the array. And I'll say while I is less than numbers.length. And then we'll increment I. Okay. If the current number is smaller than the smallest number, so let's create a variable for the current number, and that's just going to be numbers at I. And then we'll say if the current number is smaller than the smallest number. So if current number is less than the smallest number, then we will set the smallest number to be the second smallest number. So basically the smallest number is going to shift up. So second smallest is going to be the smallest number, and set the current number to the smallest number. So now smallest number is the current number. You know when you repeat a word over and over again, it starts to sound weird? Smallest. That's a weird word. Okay. So we have now taken care of, we just looked at this number and we set it as the smallest if it is the smallest. Else, this number might be smaller than the second number. So let's check that. So else, if the current number is smaller than the second smallest number, a weird variable there. This should just be smallest. So if current number is less than smallest, set the second smallest to be the smallest, and set the smallest number to be the current number. If the current number is less than the second smallest number, then we'll just overwrite the second smallest. So now second smallest will be the current number. And if we do this for the whole array, we should have the two smallest numbers in the array. So we want to return their sum. So return smallest plus second smallest. And let's just log out our smallest and second smallest number to see what we get. Okay. Let's, oh, I pressed Command S and it saved. But so that seems to work. If I run the sample test, it works, and we can see for all of these sample tests, it found the two smallest numbers, and yeah, it seems to work. So here's what I want to do. I want to rewrite this using some built-in methods in JavaScript instead. So I'm going to create this locally so we can run it a few different ways. Let's call this smallest. What is this called? Sum of two lowest positive integers. Let's call this sum of two lowest.js. So we'll keep that function, but let's write it again using built-in method. And why is there a semicolon there? There shouldn't be. Okay, so built into JavaScript is this function on math called math.min. And this accepts two numbers, or actually it accepts any number of numbers. So one thing we can do is we can't just pass in numbers because numbers is an array. So one thing we can do is we can call or apply this array of numbers as arguments to this function. So if I do math.min.apply, apply, the first argument is the this argument. We don't need a this argument. And then the second argument is an array of all the arguments we want to call math.min with. So this will give us the lowest number in the array. So let's say smallest is going to be math.min.apply null and numbers. And let's just log that out. And then let's test it with these. We'll just do a console.log of those. But we should see the smallest number logged for each of these arrays. Let's see what happens. So 5 is the smallest number in this array. 2 is the smallest number in that array. And so this is essentially taking this array of numbers and calling it with math.min. Then we would want to do that again, but we would want to do it with the array without the smallest number inside of it. So what we could do is we could say second smallest could be that same thing, but applied with the array that doesn't have that value inside of it. This is my break timer. Let's take a quick stretch. So second smallest, basically we want to take the number out of that array so we could really just filter it. So we could say math.min.apply, and we want to take numbers and filter it for any number that is not the second smallest number. Actually, this might not work if it has the same number twice. Let's see what happens though. So let's do where num is not equal to smallest. And so this will give us an array without the smallest number in there and then apply it to math.min. So let's find the smallest and the second smallest. Let's see what this does for us. So 5 and 8, 2 and 4, 3 and 7, 1 and 23, 4 and 12. So that seems to be working. And then we just want to return their sum. So if we try that, 13. wait, what is this logging? Oh yeah, so it's logging what is my sum, what's the expected sum. So that seems to work. Let's try this on CodeWars. Maybe they pass us in an array that has two numbers that are the same and it might not work. So it works for the sample test. Let's do an attempt. Yeah, and then it seems to fail. Let's log those smallest. Yeah, expected 24, got 28. My guess is that we are pulling out the same thing twice, and we only want to pull it out once. So let's see how we could do that. Really, we could just do a for loop. Right now I'm not thinking of any built-in methods to pull it out. There is like some every. One thing we could do is say grab the index, like the first index. So we can say smallest index is numbers dot index of numbers. So of smallest, and that'll give us the first index in the array. And if we pull that index out, so if we splice it out, then we would not get rid of both of them. So this should work. I think it said in the description, though, that we're not supposed to modify the array. Hint, do not modify the original array. So here's what we can do. We can say numbers dot splice. Splice will create a copy of the array. So copy the array and then slice out the smallest index and one of those. So this will give us an array without that smallest number, but if it was in there twice, it'll still be in there. So let's see if this works for this attempt. Oh no! Let's see what I did. Oh, you know what? I need to store this in an array because that doesn't actually return the array. So let's say numbers without smallest is that, and then we'll pass that into second smallest. And if I run this locally, infinity, what? Let's see. I believe splice makes a copy. Let's double check. Splice removes elements from an array, and if I mixed them up. It should be slice to make a copy, and then splice to pull it out. Okay, that should work. There we go. And now if we try this on CodeWars, let's see what it tells us. That broke. What? Let's try it with the sample tests. It breaks there too. Was I not getting the right number locally? Okay, smallest is the minimum of the entire array. The smallest index is going to be the index of that smallest one. And then we're going to splice out that smallest index. Actually, that's why. Because splice doesn't return an array. So first, copy the array, then splice it out, because splice modifies it. That was my issue. So you can't chain those because splice doesn't return a new array. It modifies the existing array. Okay. There we go. That does it. Now let's try it on CodeWars. Sample tests. That works. Attempt. That works. Cool. One last way I'll show this is instead of doing apply, ES 2015 introduced the spread operator, and that makes it a little bit cleaner. So instead of doing apply, we can just say ... numbers. And what that does is it spreads the array as parameters to call the function. So this will work in exactly the same way, but this is just new fancy syntax that doesn't require as much. We don't have to think about what is the this value and are we applying it. We're just saying take this array and call this function with all of the things in the array as parameters. And so this should work the same way. Cool. And I think I'll submit this solution. The reason I like this solution is because it's a single iteration of the array. we start at the beginning and then we get to the end and we have found the two smallest numbers. This is multiple iterations. So this is one iteration to find the lowest number. And then this is one iteration to find the index. This is an iteration to copy it. This is one more iteration to find the next min number. So this, even though this doesn't have as much logic in it, it is a lot more iteration of the array. So I'm going to go with this first one that I wrote and submit it. Attempt. Submit final. I think that worked. Running. I think we need a sound for this. We did it. Cool. Here's some other solutions I didn't think of. So here's what they did. They sorted the array and then returned the two first numbers in the array after it was sorted. That makes sense. This, depending on what sort algorithm the JavaScript engine could actually will perform not as well as a single iteration, because sorting at best is in log n complexity, n times log n, whereas this solution is just order n. We iterate once over the array and we have this the two smallest numbers, and this is like one iteration and some changed, and depending on the sorting algorithm could be n squared, meaning it has to have like a nested for loop. Okay, this is a similar solution, but instead of setting it to the two first values in the array, they set it to like the maximum possible integer in JavaScript. Cool. So sort the array, grab the first two values, and then reduce that to get its sum. These are all clever. Mine is the most performant. All right, let's keep moving. Next one is credit card mask. Brett, welcome to the stream. All right. Usually when you buy something, you're asked whether your credit card number, phone number, or answer to your most secret question is still correct. However, since someone could look over your shoulder, you don't want that to be shown on your screen. Instead, we mask it. So your task is to write a function maskify, which changes all but the last four characters into pound or hash. So if we pass in this, we get everything except the last four numbers. And yeah, let's do it. And they can pass in things that aren't even just like a credit card number. It looks like they're passing in literally anything, and you just want to keep the last four numbers as not being hidden. Hey Bob, welcome to the chat. Welcome to the stream. Okay. Let's do this. So here's what I'm thinking. We could, and actually, are we getting in a string or are we getting in an array? Yeah, we are getting in a string. That's fine. So here's what I want to do. I want to iterate over the string in reverse. So start at the end and go to the beginning. So iterate over the string in reverse. If the current index, and actually we'll need a place to store the masked number. So a place to store the masked number. If the current index is greater than, we'll have to do a little bit of math because we're going in reverse, but if the current index is greater than length -4, append the number to the masked number. So if we're iterating in reverse, if we're at any of those last four numbers, I'm gonna have to work on this math right here. But if we're at any of the last four numbers, then we will just append the numbers themselves or letters, whatever they are in the string, to the masked number. Otherwise, just append a mask. And that should do it. We will return the masked number. Okay, let's give it a try. So say let masked be equal to an empty string, so it starts off as nothing. And then we're going to iterate over the string in reverse. So I'm going to say for let I equal the length of the input -1. So that will be the very last index of the input. And we'll say while I is greater than or equal to 0. I minus minus. So this is a for loop, but it's going in reverse. Okay. If the current index is greater than length minus 4, I think this is the right math because we're going to length minus 1. Yeah. And we would want to do -3. Maybe it needs to be -5. Let's do it. Okay, so if I is less than, or sorry, is greater than the length -4. And let's think about this before we just throw numbers into it. I got a whiteboard. let me write this out. So actually, I need to do this. Okay, so let's say we're given the string like 1, 2, 3, 4, 5, 6, 7, 8, 9. The length of this is 9, so length is 9. And we want to go all the way to here without setting it as masked. So if length is 9, we want to go to index, wait, what's my logic? Length -4. So 9 minus 4 would give us 6. 9, 8, 7, 6, 5. 5. I can do math, I think. So while the index is less than 5, so if we go to 0, 1, 2, 3, 4, 5, that's pointing at 6. And this is I equals 5. So if we go to here, we actually want to go -5, I think, because if the index is less than this number, that's when we want to start doing masks. So this actually needs to be -5 because that will give us index 4. So this is where we want to start the mask. So we say this will be index 9, 8, 7, 6, and that's less than 5. But then when the index is 5, that's not less than 5, so we do mask. That's what we want. Okay, so -5, then we're going to append that number to the masked number. So we're going to say masked plus equal, and let's just store that, not the number, the letter, sorry. Because it could be either a string or a credit card number. So let's store this in a variable. And this is going to be cc at I. And so then we'll just add the letter itself to masked. Otherwise, we're just going to append a pound. And then we will return the masked number. Okay. I think I got it wrong. I think my math might be off. Oh, no, we're appending it in the wrong direction. So instead of appending it, instead of doing a plus equal, we'll have to do letter plus masked. Because that will take whatever masked is and put it on the end. Wait, no. Let's see. So expected this, instead got this, because right now we're just appending it at the beginning. Yeah, we need to be appending it at the end. So this will take whatever it is and put that value on the end. Or I need to flip that. let's see. I may need to, yeah, I think I need to flip it. I guess I'm thinking about it differently because we're going in reverse. Whoa, whoa. Yeah, so this needs to be letter plus masked. So put that thing at the beginning of it. And that makes sense because this will start off as an empty string, and then we're going to put at the beginning of it the last character. And then it will be the last character, and we're going to put the next character at the beginning of that. So that makes sense. There we go. Let's try it with more tests. Wait, is that going to submit my final? Don't do that. No! I want to try it again. Can I stop it? Oh, well, if it submits, I'm going to redo it because I want to use some built-in methods. We could probably use a reduce. Yeah, let's use a reduce. Train again. Okay, so let's bring this down locally. Credit card mask.js. So that worked. It's a single iteration of the string. Let's try it again, but let's try to use some built-in methods because we are doing iteration. We're essentially reducing this input to an input that has pounds inside of it. So I think we can use a reduce for this. Actually, we could probably use a map because we could have this logic inside the map to say which one to return, and we could do it on something reversed. Let's see. So let's say we first turn it into an array. So let's say let input array. This is going to be this dot split on the empty string. So my break timer, let's take a quick stretch. Whew. So split on the empty string, and then do we want to reverse it? No. I guess technically we could have gone in the other direction as well and just flipped our logic for the if. So yeah, let's just do that, and then we'll map it. This will give us the letter. And a map also gives you access to the index in the array, so we could have similar logic. So we could say if index is less than, and a map also gives you access to the array. So if index is less than array.length minus 5, that means we're before the last few characters, so we want to return pound. Otherwise, we want to return the letter. And then we're, yeah. So we'll be iterating over, and essentially all the way until we get to the last 4 characters, we're returning a pound. And then when we get to the last 4 characters, we are returning the letter itself. And then we could just join that back together on the empty string. And actually, I'll rewrite this, but instead of going in reverse, we'll go in the other direction because it should work with the exact same logic. So let's see if this works. Sample tests. Ah, we're off by 1. Cool. If we do the attempt, That works too. All right, let's rewrite this. Instead of going in reverse, we'll go in the other direction. So instead of doing a reverse loop, we'll do 0, and then we'll say while I is less than the length, increment I. And if I is less than the length minus 4, we'll add a pound. And actually, because we're not going in reverse anymore, we can just do a plus equal. And then in this case, we'll add the letter itself. And then we return masked. So this should work too. Oh, are we not appending? Oh, this shouldn't be masked. This should be pound. So we want to append the, when we're before the last 4 indices, we want to append a pound instead of the letter. There we go. Attempt. Cool. And I'll submit this one. And again, I like it because it's a single iteration. This is 3 iterations. We have to split it, turn it into an array. That's 1 iteration. Then we map it, so that's another iteration. And then we join it, so that's another iteration. Before, when I submitted it, I saw an example of like regex, and that's potentially multiple iterations of the string. I don't know. It's not, maybe not the prettiest code, but it would be the most performant code. Submit final. Working, drum roll. Cool, it worked. So, let's see what this does. So a slice will, yeah, so this takes out a piece of the array, copies a portion of the array. So if you pass in a negative index, it's actually going to take away from the back of the index. So this is pulling off the last 4 and then replacing it with a pound. Actually, so this is replacing everything except for the last 4 indices with a pound. And then this is just going to grab the first 4 of the array itself. Oh, interesting. So this is a regular expression that says it's 0 more of anything, but these 4 dots somehow, I'm not the best with regular expressions, but these last 4 dots say somehow save those last 4 characters and replace everything else with a pound. And there's another regular expression to do that. Cool. And so I see people doing this a lot when they're working with strings in JavaScript, but because strings in JavaScript do support the indexing into them with brackets, you don't need to turn them into arrays. So like in this case, they're creating an array to split it so that they can iterate over it, and then they're replacing the values inside of that array and then joining it back together. But this could have just as well been done with just string concatenation rather than turning it into an array and then turning back into a string. Hey, Emmy. They've been going decent. We're on number 2, and we're about to move on to a little bit more harder. So this one was a 7Q. Yeah, that was fun. On to the next one. All right. This one is create phone number, and it's a 6Q. Write a function that accepts an array of 10 integers between 0 and 9 that returns a string of those numbers in the form of a phone number. So we get an array, and we want to turn that into the format first 3 numbers in parentheses, space, next 3 numbers, dash, last 4 numbers. The return format must be in the correct order to complete the challenge. Don't forget the space after the closing parentheses. Datums! Welcome to the stream. Awesome. Are you the datums that I think you are? Even if you're not, welcome to the stream. Okay, let's try it. So let's copy our example format. So ultimately, we want to end up with this. Yeah, we could be very manual about this. I think I'll do that first. So we'll do like, what if you didn't even know what a for loop was? You could still solve this problem. Then we'll maybe do something with a for loop, and then we can probably do like a reduce or something like that. Okay, so let's just say we'll have a place to store the phone number. That is the datums I thought it was. Awesome. A place to store the phone number, and then we'll just index into the array and start appending it. So we will append a paren, and then append the first 3 numbers in the array, and then append a closing paren, and then append a space, not append space, and then append the next 3 numbers in the array, and then append a dash, and then append the last 3 numbers in the array. Cool. And then return the phone number. Cool. And let's just do this manually first, and then we'll use some built-in methods to kind of help us out. So a place to store the phone number, let's just say let phone number equal an empty string. And we want to append the first parenthesis. How about we just start off the phone number with a parenthesis in front of it? And then we're going to append the first 3 numbers in the array. So let's say phone number plus equal numbers at 0, numbers at 1, and numbers at 2. Then we will append a parenthesis, phone number. Append a parenthesis and a space. We'll just do that all in one go there. And then append the next 3 numbers. So this is going to be 3, 4, and 5. Cool. And then append a dash. So phone number plus equal a dash. And then append the last 3 numbers. So this is going to be 6, 7, 1, 2, 3, 4, 5, 6, 7. Oh, the last 4 numbers. Sorry. 7, 8, and number 9. Cool. This is really ugly. We could make this look a lot prettier, but let's just see if it works. What? Let's take a quick break. Kaizen in the chat says, I need to do some katas again. Are you getting rusty with your programming? How the heck did that happen? Let's see. We shouldn't have to wrap this in parentheses, huh? Because for whatever reason, this is only grabbing the first one for this line of code. Oh, they're actual numbers, so it's doing math. So we need to actually convert these numbers into strings. That's a tricky thing. Let's do this. Yeah, so because these are numbers, it's giving us a single number that's actually them added up. So we could do a toString on each one of these. And that way it won't try to do math on us. Actually, There's a trick where I could like make the first thing that it's appending a string, and then the rest of it would become a string and not do math. Let's see if this works, and then I'll try that, and then we'll make it even cleaner. So run the sample tests. There we go. That's what we wanted. Okay. Here's what I'm thinking though. So instead of doing this toString thing, actually, let me save all this locally so you can see the many different solutions. So here, what is this called? Create phone number. So there's that. It's like very manual. But if you know anything about coercion in JavaScript, if you have a statement that starts with a string, then everything else after that becomes a string. I'm pretty sure. Let's try it. But here's what I'm thinking. So instead of doing this toString thing, we could say empty string plus those next things. And I think JavaScript will coerce everything else to be a string and append without doing the maths. Let's see. We can test it locally with this. Yeah, so Datums is recommending a template string. Definitely. So we could use a template string. Oh, I see what you're saying, though. Yeah, so instead of doing appending, we could do a template string that has each of the values inside of it. That won't do math. Absolutely. Let's see if this works, and then we'll do that, and then we'll do another thing that instead of having to manually pick out these numbers, we can just like grab a copy of a portion of the array. Okay, let's try this. That works. And the reason this works is because of coercion in JavaScript. So because the first thing that JavaScript sees is a string, the end result is going to be a string. And so instead of actually doing math, it just appends these things. It coerces them to strings and appends it. So that's one way. Cool. Let's do a template string like Datums is recommending. So instead of doing this weird put a string at the beginning, let's put all of this in backticks, and then we'll bring in each individual value. So, So I want numbers at 0. I want numbers at 1. And I want numbers at 2. Yeah, so this is ES 2015 template literal syntax. So we're basically creating a string that has these 3 values in it. So that won't try to do addition on them. And then we can do the same thing for all of these. We'll just have to say 3, 4, 5, 6, 7, 8, and 9. And this should do it too. Unexpected token. I have a extra parenthesis. What? Is that in the previous one? Oh, the previous one I still have that on there. Yeah, don't want that. Cool, that works. But let's go even further with this. So let's use a template string for the whole thing. So instead of doing multiple lines of concatenation, we can have one big long template string that does the whole thing for us. So let's say we want a template string that starts with a parenthesis, followed by a space, followed by these things, followed by a dash, followed by the last 4 numbers. Whoa, what just happened? What are you doing, VS Code? Yeah, don't do that. Oh, I copied the I copied the backticks. I don't want the backticks. I just want that. Cool. So it's kind of hard to read because it's all on one line, but let's do this. Basically, we have created a single template literal that does what we want. So the first three numbers are wrapped in parentheses, followed by a space, next three numbers dash, and then the last four numbers. So let's see if this does what we want. There we go. All right. The last cleanup of this is instead of having to pick out these three numbers individually, let's use a slice, which will create a copy of just a specific portion of the array and put that in here. So right here, we want to do numbers.slice, and will Visual Studio Code help me? It usually gives me a description. Here, I'm going to restart Visual Studio Code because it has stopped being helpful. Go away. Yeah, so I just switched to Visual Studio Code probably like week and a half ago, 2 weeks ago. And this seems to be happening to me all the time. All of a sudden, my autocomplete will stop working, and syntax highlighting gets really weird, and then I have to restart Visual Studio Code. I've never had to do that with Atom. Okay, let's try. So numbers.slice. Well, maybe it won't. Okay, but the start number and then the end number is non-inclusive, I believe. So if we say 3, that will be indice 2. Yeah, Kaizen in the chat says VS Code's like, nah, it's okay. He knows what he's doing. Yeah, I mean, I could code this without all the autocomplete, but I would prefer it. And then we want to just join that on the empty string. So that'll give us the first three numbers. And then we want the next three numbers. So we'll start at indice 3, and we want to go to indice 7 because it's non-inclusive. And then, we'll start at indice 7. 7? Yeah. And then I think if you leave off the last number, it just says, okay, to the end of the array. Let's see what this does for us. It works. Cool. Yeah, I mean, that's a thing. Kaizen says, it's not a bug, it's an AI feature. So yeah, so that works. One other thing we could do, though, is we could iterate over the whole array and say, if we're at indice 0, append a parenthesis in front. If we're at indice 3, append a closing parenthesis and a space. If we're at indice 6, append a dash. Like, we could iterate over the whole thing. There are 1,000,001 different ways to do this thing. Let's submit. I think I'll submit this nice little template string one. We could clean this up, though, because, like, this is, like, really long, I feel like. Let's create, like, a one variable function that does a join. So let's say const j is a function that takes in an array of numbers and then just returns them joined on the empty string. So then we can make this just say j. Look at that. Okay. J. I should do it. It did it. Oh, wait. Yeah, I did it. Cool. We could make this even smaller. We could, let's take in the beginning index, the ending index, and the array. So we'll take in the array. We'll take in the beginning index, the end, and the end index, and we'll say in.slice on the beginning to the end, and then join it. Now we can just get rid of this slice. So j that, j that, j that. Will it work? Well, that's weird. Oh, we also have to pass in the indices. So j with numbers 0, 3, and then j with numbers 3, 7, and then j with numbers 7. And this last one should work because the third parameter will be undefined, so it should just give us the end of the array. Yes. Can this be a regular expression? Definitely. We could say, well, we're given an input array is the thing. So we could turn this into a string and then use a regular expression to turn it into a phone number. Let's do that. How long have I been streaming? I feel like I've spent a very long time on this one. Close to an hour. That's okay. Let's do this with a regular expression because that would be fun. So here's what we want to do. We want to say, let's get rid of this comment. So let's do numbers.join on the empty string. So now we have a string. And then we want to do a matcher. So we want to match the first three numbers. Actually, I guess we could do a replace. And then our regular expression is going to be find 3 digits. So let's just look up the regex to do digits. Find a 1-digit number. And yeah, so this will let us find the first 3 digits. And then I guess if we wrap this in parentheses, that should give us a group. And then we want to find the next 3. And then we want to find the next 4. So this is going to match the first 3, the next 3, the next 4. I'm not sure how to do this with JavaScript though, but basically we want to say like our resulting string is going to have this with like $1 space $2. So like our second group dash our third group. Like that. Do you know how to do this in JavaScript, Kaizen? Might have to look it up, but because basically we want to match those 3 things and then pull out what was matched for each and put it into a string like that. Let's see if this works. I don't know if that's how you do matchers in regex with JavaScript. Whew. And then we'll just return this. It worked. Really? That's surprising. Cool. But the way this works is we turn it into a string. We grab out, add the space and the dash in the regex itself. I don't think so because the thing we're regexing over is just a string that has all of the values in it. So we're not going to find the parentheses or the dashes in the string itself. So what I'm saying is find the first 3 numbers, find the next 3 numbers, and find the next 4 numbers. And then $1 gives you access to your first match, $2 gives you access to your next match, and then $3 gives you access to your last match. Did this really work? Let me comment out everything else and then run my code. That worked. Wow. Wow, I've never used a regex like that in JavaScript. I've done this a lot, just like regexing on Bash using sed or something like that. So that's pretty cool. Let's do this one. Kaizen says, "Damn." uh, cool. So we'll keep all of that. We'll submit this one. Hopefully it works. Sample tests. Works. Attempt. Drum roll, please. Oh, never mind. I gotta submit final. The comma thing blew Kaizen's mind right now. Do you mean the thing on the right hand side of the comma, like what the thing will become when we do the replace? I can't believe I've never done this in JavaScript. Like this changes how I would do a lot of things, because it makes it a lot easier to do, like, find this inside of the string and create a new string that is like the result of finding that thing. Okay, submit final. Drum roll, please. More drum roll. Cool. Let's see how people did it. Yeah, so instead of using see, this is super interesting. Like, why would you turn this into a string so that you can use substring? Like, why wouldn't you just use slice, because that's already built into an array, and then you wouldn't have to turn it into a string. And then, oh wow, so we have our format. We iterate over the string, and so this is not not very performant, because a replace has to search the string to find it. So basically on every iteration, a replace by default will only replace the first one. So they're replacing one x at a time with the next number. Cool. And in this case, they used a regular expression, but since we already know that everything is a number, you can just use a dot to match a single character. Kaizen with the champagne emoji in the chat. That's great. And then this is like the one that we did. Cool. All right. On to equal sides of an array. I'm gonna take a quick step back. Get ready for this one. Do some stretches real quick. I find that if I just keep coding, I'll get exhausted and less energetic and less entertaining. Okay. You are going to be given an array of integers. Your job is to take that array and find an index n where the sum of the integers to the left of n is equal to the sum of the integers on the right of n. And this is a 6q. If there is no index that would make this happen, return -1. Okay? Let's say you are given the array that. Your function will return index 3 because the third position of the array, the sum of the left side of the index, and the sum of the right side of the index both equal 6. See you later, Datums. Thanks for tuning in. Let's look at another one. Yeah, so basically you need to find the index in the array where to the left of that, everything has this, those numbers summed up has the same sum as the things on the right. So in this case, index 3 is 0, 1, 2, 3. So right here, everything to the left are the same numbers as on the right, so those have the same sum. So your function returns 3, because index 3 is where that happens. Let's look at another one. You are given the array 1, 150, -51, 1, and 1. Your function will return the index 1 because the first position of the array, the sum of the left side. So index 1 is here. The left-hand side is 1. That's the sum. 50 minus 51 is a -1. Plus 1 is 0. Plus 1 is 1. So the sum of this equals that. Okay. Last one. You're given the array this. At index 0, the left side is nothing, and the right side is that. they both are equal to 0. The right side is that they both are equal to 0 when added. Empty arrays are equal to 0 in this problem. So, wait, what? Yeah, the right side is 10, negative 80. Oh, negative 80. So the sum of all of those things is 0. The left-hand side of this is 0, so you get back 0. This is going to be a tricky one. Okay. And the input is an array of up to a length 1,000. So the output is the lowest index, where the left-hand side is the same, has the same sum as the right-hand side. Okay, if you're given an array with multiple answers, return the lowest correct index, so the leftmost index. An empty array should be treated like a 0 in this problem. All right, let's give it a try. It's gonna be tricky. All right, and let's take like an example array like this one. Pijo, welcome to the stream. We have been going for an hour and 6 minutes, but I have a few more that I want to do, and they're all not that easy, so I might be streaming for a little bit longer, but welcome to the stream. We're on a 6Q. And I just realized I'm basically doing like interview problems live on the internet and having fun while I'm doing it. Okay, so given this array, we need to find the index where everything to the left has the same sum as everything on the right. So one thing, well, here's what I think we should do. We should iterate over the array, sum the left of the index, sum the right of the index. If they are equal, return the index. Otherwise, we just keep going until we get to the end. We'll probably have to have a special case where what if we get to the end and nothing happened? But we'll account for that. So we need to do a sum. I'm just going to write a simple little helper function that sums up the array. So let's say const sum is a function that takes in an array and then reduces it. And we're going to return sum plus num. Will that do it? Start the sum at 0. Let's just try our little helper function out real quick. Sum of 1, 2, and 3 gives us 6. Cool. Here's what I want to do, though. So instead of just passing in the array, what if we pass in the indices that we want to sum inside of the array? That way, it'll be really easy inside of the iteration to just say start at index plus 1 to the end, and then start at index minus 1 to the beginning to index minus 1. So let's create a sum function that will take in the indices also. Here, I'm going to do this locally. Equal sides of the array. Cool. So we'll do this. Whoa, not that. This. Okay, so I want to create a sum function. This is going to be sum sub array. So you pass in the array, you pass in the start index and the end index, and we'll only reduce or add if we'll basically, and I'm not even going to do a reduce because I want a for loop that only goes from start to end of the array. So we'll do a for loop. We'll say let index equal start while index is less than end. Cool. And we'll do a non-inclusive end. and we'll say sum, it starts at 0, and then we're just going to add the current, so array at start, well, array at index, added to the sum, and then we'll return that sum. Pijo is saying, curry the array slices to the sum method. You can do that in JavaScript. I'm not even going to attempt that right now. I'll get this going, and then we'll see what we can do. But if you're not familiar with currying, it's a functional concept where you take a function that takes multiple parameters and create multiple functions that only take one parameter. Yeah, check that out. Let's keep going. So this function should take in an array and then just give us the sum from a specific index to another index. Great. So now let's iterate over the input array. So we'll do a for loop. Array.length. We're going to sum left of the index and sum right of the index. So let's say left sum is going to be, and we don't need the element. And we'll say sum sub array. The left of the index is going to be nothing. So let's start at -1 and go to, well, actually, we'll say start at 0 plus the current index. Because well, no, start at, yeah, just start at 0, because the left of the other array is going to be 0, and then you want to go up to the current index, so that's going to be the end. And yeah, so this should just give us back 0, because if we start at 0 and our end is 0, then this won't even go into the for loop. Cool. So the left of the array is up to 0 to the current index, and then the right of the array is going to be from the current index to array.length. And now we do the thing. So if they are equal, so if the left sum is equal to the right sum, we got it, and we will return the index. Otherwise, we keep going until we find something. And then let's see what it says to do if there was no sum. Cool. If there is no index that would make this happen, return -1. So if we get to the end of this for loop and nothing has happened, then we need to return -1. Okay, I think this will work, because this is summing the left side of the array, this is summing the right side of the array at the given index, and if they're equal, it returns it. Cool. So let's see if this works, and then see if maybe we can clean it up or curry it. And there's chatter of functional programming in the chat. Oh, don't do that. It's a quick break. Okay. Let's try with the sample tests. Oh no! Expected 3, got 0. Oh, well, it's returning 0 every time. Oh, okay. I think here's the issue. Okay, let's figure out our issue. We're always returning 0 for some reason. So if the index is 0, and we do some subarray of, oh, this needs to be index plus 1. Because the right of the array needs to start to the right of the index. Kaizen asked in the chat, what are my thoughts on pure functional programming and immutable data? I think my opinions have a lot to do with the fact that the majority of the beginning of my career was with object-oriented programming. And in object-oriented programming, you mutate state. Like that's what object-oriented programming is. You create objects, they have state, and then their state changes and they interact with each other. So I've always programmed in that fashion. I think, especially like 2 years ago, I didn't see as much of a trend this past year, but like 2 years ago, everyone in the JavaScript community was like, everything should be immutable, and I think it has its place. I also think that you have to take a totally different mindset when you're programming in that way. Like programming object-oriented and programming with mutating state is a different way of thinking and solving the problem than thinking in pure functions and immutable state. Personally, I haven't done a lot of it, so that's why I don't do it that much, but it seems cool. I think one of the things about functional programming and immutable data is it is easier to reason about your code because state isn't changing. You can also think of everything as immutable and pure. And so because state isn't changing, it's easier to reason about. But like I said, I've been programming with mutable state for almost all of my life. And so that's how I prefer to program. Sample tests. Oh no, expected 3, instead we're still returning 0? Why? Let's see. So, oh, we're not passing in the array. Oh, okay. The first parameter is the array, then the start index, and then the end index. Let's run these locally, just to make sure. What did we call this? This is equal sides sum. Assignment to a constant variable. Yeah, this should be a let. Okay, it's working now. I should learn how to call my own functions. I wasn't passing in the array or the start or the end. Sample tests. Hey, all right, let's do an attempt. Actually, we'll see if we can clean this up a bit. Hey, that worked. I am proud of myself. Yeah, and Pijo is saying in the chat, it's hard to really do anything in the real world, especially in APIs, with mostly pure functions. And the thing to think about is like an API request has side effects. Like that is not pure. So when you're building web apps, you're dealing with API requests. So everything can't be pure. But he's saying thought process should be immutable first and then mutate when needed. Definitely. Okay, let's try to clean this up. I don't know how we might. Can we make this more functional? Can we potentially use a for each instead of a instead of a for loop? It's tricky because like right now because I'm using this for loop, it will jump out of the for loop anytime like the moment it finds that index. If I'm using any other higher order function, it has to iterate over the whole array. So I like the fact that this kind of does like a short circuit. I'm gonna leave it as is because I have some harder problems coming up. But yeah. And an app I want to build soon is basically where you, the viewer, can share your code and like maybe show different versions of how you tried to solve this. And potentially we could like use it live. So like if I'm solving it and you want to share your solution, I could go to a page and like see you coding live. So that would be fun to build. Drum roll. Drum roll. One more. Why is this taking so long? Cool. Let's see how they solved it. So find. Wait. Maybe this kata got renamed. I think it did. It used to be called find even index, but they iterated. Yeah, and Pijo is saying so because if you're just joining, we were talking about like functional programming, and we could have used a higher order method, but the fact that I just want to be done, like I don't want to iterate over the whole array, I want to stop here. Pijo is saying that's a good example of when doing something non-functionally makes a little bit more sense in terms of like performance wise, because you don't want to iterate more than you have to, and I think that makes sense. Let's see how they did this. Okay, so they started at index 1, meaning they're going after the first index to the end -1. So they're leaving off the 2 last indices. If you slice the array from the beginning up to the current index, and remember slice is non-inclusive, so if you put 1 in there, that's going to give you a slice of just the first value in the array. Then they sum it, and if the right-hand side is the same, then they return that. Cool. So they're doing similar to what I did, but they're pulling out a slice of the array and then running it through reduce, whereas I just used the original array and did a sum up to 2 specific indices instead of pulling out a copy of the array. Cool. People on CodeWords like to use like very small variable names, I've found. It's interesting. Okay, on to the next one. This one actually I think should be fairly easy though. Number is a palindrome if it is equal to the number with the digits in reversed order. Yeah, I think this one should be pretty quick. And then Roman numerals encoder will be interesting. It's a 4Q. Okay. Number is a palindrome if it is equal to the number with the digits in reversed order. So for example, 5, 44, 171, 484 are palindromes because if you reverse them, it's the same number. And 43, 194, and 4773 are not palindromes. Write a method palindrome chain length, which takes a positive number and returns the number of special steps needed to obtain a palindrome. So the special step is reverse the digits, add it to the original number. If the resulting number is not a palindrome, repeat until you find a number that is a palindrome. And the number of steps, if the input number is already a palindrome, the number of steps is 0. So you need to return the number of steps it takes to get to a palindrome by doing this reverse, add, reverse, add. Input will always be a positive integer. So for example, so 87 is not a palindrome, so you add it to itself reversed. 165 is not a palindrome, so you add it to itself reversed. Repeat, repeat. Finally, we get 484, which is 1353 plus that reversed. And then the return of this function is going to be 4 because it took us 4 steps to get to that place. Okay, let's do it. Enhance. So there's our example. So I think I need a function that will tell me if the given number is a palindrome. If it is, we're done. Otherwise, flip it, reverse it, add it, do the thing, and then check if it's a palindrome again. So first I need a place to store the counts. So how many times did we go through this? We'll have a function to check if a palindrome, and then we'll have to write out the logic for that too. But then we will have maybe like a while loop. So while let's call this our current num. So while the current num is not a palindrome, we will reverse it and add it. So set current num to the reversed, num plus the current num. So that will reverse it, add it. We get our current num. We'll then check, is that a palindrome? If it's not, and inside of this while, we will increment the counts. Okay, so basically is the current number a palindrome? No, it's not. Let's add it to itself flipped, increment how many times we've done this. Is it a palindrome? No, it's not. So we'll just do that over and over again. And then lastly, we will return the count. Okay, so first we need a place to store the counts. So let's say like let count equal 0. And then we need a current number. I guess we could just use in. Let's create a variable for it. So let current num equal in. And while the current number is not a palindrome, so I want to say while is palindrome of the current number not. We will then say current number equals reverse the current number and add it to the current number. Reverse doesn't exist. I'm going to have to create that and then increment the counts. So like count plus plus. Okay, so first we need an is palindrome function to check if a number is a palindrome. And lastly, we'll return the counts. So we have a function is palindrome that takes in a number. And we want to make sure that the number in reverse is the number itself. So million and one different ways we could do this. We could turn it into a string, reverse it, compare it to itself. So let's just do that. It's easy enough. So return number is equal to number.toString. And is there a reverse on a string, or is that only on an array? No, so we'd have to turn it into an array, then reverse it, then join it. Why not? It's getting to the end of the stream. I'm getting tired. I'm writing less code. So say toString dot split. So turn it into an array and then reverse it. And then join it back together into a string. That should do it. That's a ton of iteration, but that should work. There's probably also some mathematical operation I could do to check if it's the same in reverse that it is going forward. And really, we could turn it into a string and then start checking each of the characters. Let's just do this. It's easy enough. So we'll say if the current number is not a palindrome, we'll then need to reverse. And so and actually, let's create a function called reverse, and we can actually use that here. So we'll say reverse is a function that takes in a number and does this. But we want it back as a number. So we can put a plus sign on it. That'll coerce it to a number. So reverse the number given. So turn it into a string, split it, use the built-in reverse method on an array, and then join it back into a string, then turn it back into a number. Okay, so that will turn it into a number. And wait. No, okay, yeah. And let's actually do this to string. And so we'll be able to say reverse the number, send it to a string. So if the number as a string reversed as a string is equal, then we know that it's a palindrome. Okay. Then we'll reverse it, which turns it into a number, and we'll add it back to itself. Let's see what happens. I don't like all of this that's happening. That really will reduce performance, but let's see what we got so far. Test passed. If we do an attempt, I wonder if it's going to try with like really long numbers and then my solution will break. It worked. Okay. Here, I'm going to bring it down locally and see if there's anything we can do to make it a little bit nicer. So palindrome chain length. Okay. I wonder if there's a purely mathematical way to reverse a number. And actually, do I need to turn it into a string when we compare it? No, because 484 is equal to 484. So a palindromic number is a number that's just equal to itself, right? Of course, of course. So I don't even need to turn this into a string. And let's do a quick test locally. So that's working. Cool. Yeah, let's just look. Is there a way to reverse a number? So math, reverse digits in number. Number theory, how to reverse the digits of a number. Is there a mathematical way to reverse the digits of an integer mathematically, for example? Okay, this is a pretty complex formula. I mean, we could get the length. We would then know that we could do a mod, not a mod, then we could divide it by 1 followed by that many zeros. That would give us that digit. We could then add that to the next thing, but multiplied by 10. Oh, okay. It's possible, but do I want to spend the time writing it? Let's find another thing out there. Reverse mathematics. No, not that. How to reverse a number as an integer and not as a string in C#. Okay, so this is the formula. It seems pretty easy. We could convert this to JavaScript. So you have your starting number. Left is going to be equal to that number, and then reversed is 0. So while left is greater than the number, left mod 10. So that's going to grab the mod 10 we'll grab the first digit. Let's see. Let's take a quick break. Oh, well, as a hackish one-liner. Yeah, and this is what we're doing right now. Like, we're turning it into a string and then into an array because strings in JavaScript don't have a reverse method. So toString reverse aggregate. So that's still turning it into a string. So while the number is greater than 0, you set result equal to 0 times 10. So 10 plus the tens place of the number, and then drop the tens place. This will work. Let's just do it, because I don't like this. This is like a lot of unnecessary things happening when we really just want to reverse the number. Okay. Briggs is asking what app is that? Are you referring to my code editor? I am using VS Code, Visual Studio Code. And we're writing solutions on codewords. codewords.com. Okay, but we need to turn this into JavaScript because we're not in C#. So let's say let result equals 0. And let's just call this num. Look at that. We just turned C# into JavaScript. And that will return the result. Let's see if this still works. Do I have an infinite loop? I think I have an infinite loop. Oh, Briggs is asking the app that reminds me to take breaks. That is, and I'm sorry, the chat is a little bit delayed, so sometimes I don't know what questions refer to. But I'm on Mac. This thing is called Deja by Timeout. Pijo, do you wanna you're doing a reverse with just math? I'd like to check it out. You can put it on like CodePen and then just send me like the short code. But Deja is what I use for breaks. I have it set up for a 10-second micro break every 15 minutes and then a 5-minute break every 60 minutes. If you're on Windows, there's an app called iLeo. It does a very similar thing, kind of like a full screen overlay. Yeah. So this broke. Why did it broke? Oh, wait. For is palindrome, we just say is the number equal to the number. But we still need our reverse function for this thing right here. But yeah, this could... Okay, let's put it back to the way I had it. Silly me. Okay, so that can be that. But we don't actually need to reverse it for is palindrome. Because a palindromic number is equal to itself because it's the same forward and backwards. I think. Yeah. Okay, never mind. Cool. I think I'm going to move on. How long have I been streaming? Hour and 36 minutes. Yeah, I'm going to move on. Pijo, if you want to send me your number reverse method, I'll give it a try. But I am going to move on to the last challenge of the night, Roman numerals. So let's submit the final version of this real quick. Drum roll, please. We did it. Let's see what other people did. Is palindromic only works for positive numbers? Okay, well, we didn't take that into account, but they didn't test for it. Oh, this is their function to reverse a number. So you start your result at 0. This is exactly, it's similar to what I tried to do. It's not the exact same. You start your number at 0. And then while n has a value, so whenever n is 0, this will break out because of like truthy falsy in JavaScript. You take the result and multiply it by 10. And then so that's going to give us initially 0. And then you add the last digit of the number. And then you multiply it by 10 and you add, we're shifting places. So you multiply it by 10, add the last digit, multiply it by 10, add the last digit. So it's like shifting the digits to the front. That's cool. I like that. Okay. Last one of the night, Roman numerals. Okay. Create a function taking a positive integer as its parameter and returning a string containing the Roman numeral representation of that integer. So modern Roman numerals are written by expressing each digit separately, starting with the leftmost digit and skipping any digit with a value of 0. In Roman numerals, 1990 is rendered. There's 1,000, so you get an M. There's 900 left over, so you get a CM. Oh, and you're putting everything at the front. 90 is XC, resulting in MC MXC. Wait, how does this work? Okay, so here's the symbols that we can use. So 1000 is M, 990 is CM. Oh, this is gonna be hard because it's 100. It's M minus C gives us 900, and then XC is 100 minus 10 that gives us 90, resulting in MC MXC. Okay, and then 2008 is written as 2000 is MM, it's 2000s, and then 8 is written as 5, 6, 7, 8, so VIII. And then altogether, that's MMVIII. Tricky one. Okay. 1666 uses each Roman numeral in descending order. So you get an M because there's 1,000 in it. And then for 666, you're going to have a D with 100 left over, so you'll have a C. With 60 left over, so you'll have an L. With 10 left over, so you'll have an X. With 6 left over, so you'll have a V. And then with I left over, you'll have a 1. Okay, that honestly makes it sound a little bit easier because you're basically just using the biggest possible number to get to that number and then moving on to the next one after you've reached it. Okay. Remember that there can't be more than 3 identical symbols in a row. Oh, but no, it's gonna be tricky. Let's do it though. Okay, so this is our like lookup table. It's train. And also let's throw in some examples to help us out while we're doing this. So these. Okay. So I think the part that is tricky to me is that like 900 is CM because that's 1000 minus M. I mean, sorry, 1000 is minus 100. That gives you 900. And then 90 is XC, which is 100 minus 10. So how are we going to determine if we need to do that? Okay, first thing though, I'm going to take this lookup table and turn it into an object because that will be easy to access specific things by their character. So I is 1, V is 5. Actually, before I do this, let's write out some pseudocode to figure out how we're going to do this. And also let's look at the examples that they're giving us down here. And I'm going to do this one locally because it's going to take some work. Okay, those are our tests. This is our code we're going to write. And this is going to be a console log. Okay, let's handle the basic case. 1 should return I. So for this case, I'm just going to say if the number that they're passing in is in an object where the keys are the numbers and the values are that, just return that. It's simple enough. So let's create an object. So this is our lookup where the key is the number, so 1, and the value is what is that Roman numeral. So 5 will then be V, and 10 will then be X, and L will then be 50 will then be L, and 100 will then be C, and 1000 will then be M. Okay, so we got our lookup table, and then let's just check. Easiest case, the number they passed in is in this lookup table, so we return that. So let's say if lookup at that number, then just return lookup at that number. Instead of returning it, let's like build it up, because I think we can start to wrap this logic as we figure out what to do with each thing. So like, let's say Roman starts off as an empty string. And then if when we look that number up, we find it, so then we just append the lookup to the Roman numeral. This is my break timer. I have a suggestion in the chat. I should add 9, 40, and 90, etc. to the lookup. So I guess that could help. So like if we have, yeah, honestly, so like if I made like a really big lookup table, so like basically all possible versions of this. So like yeah, I like that, because when you're writing Roman numerals, I guess when you get to 4, it's VI. Yeah, I like the way you think, Alex Tube. Let's do this real quick, because this should work for like the basic case. So when the number that they asked for is in there, apologies, especially if you're wearing headphones, apologies, then just return that. So this should work for our very first case. Lookup is not a function. No, it's not. So we need to use square brackets, because it's an object. Cool. And then like the special cases are like right. I think that's where I was getting cut off. So like the special cases are like right before that number is a compound case. So like 4 is VI, IV, IV, and 9 is IX. And if we wanted to represent 8, it would be 5 plus III, right? Right? Okay, so we can start to do some math to figure out what there are. Okay, I'm getting less nervous now. Okay, so 4, 90, 40. Off topic, what kind of mic do I use? So I have a condenser mic. I just got it at Guitar Center. It was a pack of 2 condenser mics, like one. I don't know if I can show this in the best way. So it's a condenser mic. I have a pop filter. The brand is Sterling Audio, so it's nothing special. I think if you were to buy it alone, it's probably like $50. And then I have that plugged into a USB audio interface with phantom power. Briggs is saying I can add 7, 8, 20, and 30, or would that be too much? I want to add the special cases where I'm not just adding up a bunch of i's, because 1 is I, 2 is II, 3 is III, 4 is the previous value, VI. And then, and mainly I just want to do it where those numbers we will actually use. So 40 be the next one we want, because 20 is XX, yeah? But 40 will be XL, I believe. Because the number that we're subtracting from that, yeah. And then 90 is going to be 10 minus 100. So it's the next number with what you're going to be subtracting from it. And then this is the next number with what you're going to be subtracting from it. 90 yeah. Because 700 would be, actually, do we have one for 500? Am I missing 500? I am. Why am I missing 500? So we have 90. We need yeah, because if I wanted to represent 400, that would just be CCC. Kaizen, see you later. Auditing exams. Good luck. Good luck. So yeah, 400 would be CCC. Sorry, 400 would be DC or CD. Because it's 500 minus 100. Right? Right. So what I'm doing is like all possible cases of the single letters subtracted from some other value. And then 900. What was 900? CM. Because that's 1000 minus 100. Okay, are these all possible combinations? And then otherwise, you just take the previous number multiple times. So 60 would be L plus 10, so LX. Right, okay. And so basically what I want to do is use math to grab off the tens digits. So 1,000. Is 1,000 in my lookup table? Then grab that letter. If the value that I want is not in the lookup table, then I need to take its multiple and put multiple of that value in the result. So CM, yeah, because then 800 would just be I don't even know. Let's see. Is there an algorithm for converting a number to Roman numerals? Maybe I'll just follow the algorithm because I am getting tired. I've been streaming for a long time and I cannot think straight. So let's do this. Let's say decimal number to Roman numeral algorithm. I would recommend reviewing the site, which also has a converter. If we're looking for an algorithm, see this on project Roman numerals are based on the following symbols. Cool. So yeah, and I guess it might be easier if we look at like a larger table too. So 1, 2, 3, special case. 5, 6, 7, 8, special case. 10, 20, 30, 40, 50, 60, 70, 80, 90. Yeah, this would work though. How big are the numbers that they're going to pass in? 2007? Because here's what we could do. 2000 is... Wait, do we have... I thought we had 1,000. Is M. So it would have MM, because it goes in there twice. And then we're just left over with 7. So 7 in our lookup table is VII. Yeah. These are the numbers that I want in my lookup table. And then I can do basic math to get the different places to build up my Roman numeral. That is what I will do. Let's see if this has an actual algorithm. Cool. Let's just use this lookup. I don't feel like it's cheating because it's getting late. Okay, so 1, 2, 3, 4. And I guess the idea is once I have this lookup table, it's just a matter of math to figure out what are the different places in the number that they give me, and then I look them up in this table. So 5 is 6, 7, whoa, and then 8, VII, and then 9 is IX, and then 10 is X, and 11 will be XI. Wait, no, I don't need 11. I need the ones place, the tens place, and the hundreds place. So then I need 10, I need 20. I need 30, 40, 50, 60, 70, 80, 90, 100, 200. Once I figure this out, there will be a way to clean this up to not have such a big lookup object. Yeah, so AlexTube is saying I could enumerate the lookup and then subtracting the largest possible from the remainder of the number. That's, yeah, and that's kind of my plan. I'm going to do like, so given 1990, I'm going to take 1,000 and get it from my lookup table. Then I'm going to take 900 and get it from my lookup table. Then I'm going to take 90, grab it from my lookup table. Then I'm going to grab this, and then that's not there. And in this case, I'll take 2,000, grab it from my lookup table. What's left over is 8, and I'll grab that from my lookup table. So I'm going to be moving through the different places. Yeah, I guess what AlexTube is saying is for my lookup table, I don't need to do potentially the ones that aren't the special case, which is like the subtraction. Yeah, because it's 50. LX is 50 plus 10. So if I go back to the lookup table that I had, which was not including these. But the issue that I'm having is given the current number, what will I know to look up in the table? I'm going to solve it this way, and then we'll clean it up, though. I'm honestly having a hard time thinking straight tonight. So 90s place, 100s place, 700s place, 800s place, DCC. And then 900 CM and 1,000 CM. Okay, so this is messy, Wemo, I cannot see your solution. Um, if you want to send me, you can't post a URL, so I don't see any URL if you did post it. But if you do want to post like code pin and then the ID, I'll look that up. Or wherever you post it on, don't put the URL, just say where it is and what is the ID of the thing, and I'll pull that up for sure. Okay, so this is messy. I'm gonna solve it this way, and then we'll make it better. But basically, I have the values for all possible places in a number, right? So up to numbers in the thousands. So here's what I do. I take my number and I divide it by 1,000. So how many times does it go into 1,000? Oh, actually, sorry, divide, yeah, and grab the tens place. So I want to grab 1,000 and then look it up. So let's take a quick break. So how many thousands do I have in my number? So number divided by 1,000, right? Grounded orangered memory is Wemo in the chat. What is the site that is on? Is that CodePen? I guess they're giving us a basic formula here too. This might work. Oh, I'm not thinking straight tonight. So breaking 1984 into 1,000, 980 and 4, then do each conversion. So 1,000 is M, 900 is CM. So you take the number after the larger one. Wemo! Can I Google this? Is it a code pin? Oh, REPL.it. No worries. Should just be slash. Gonna copy this. Maybe that's not how the URL works. JavaScript. Okay, REPLs slash that number. Okay, so we've got our basic lookup table. And then we are going over the length of the input. And I guess, is our input a string? Input is actually a number, so we'd have to convert it to a string to be able to do length. But then letter will be Roman at what is the input to this? Because if I do one doesn't have a length, I don't think. So are you passing in a string that we're converting? And yeah, so then we're grabbing the first digit, and then we're looking in the table to see if that number is in there. And then we're grabbing the next value in the input value. So if we call this thing, this is going to be a solution invoked with, like, say 1990. Wemo, let me know how you're calling this function. The code kata you're looking at has a string input. This is a for Caillou. The way they're testing it is passing in a number. I'll throw this in the chat. Yeah, but when I passed in 1990, it got getting back nan. Oh, are you doing the reverse conversion? Like IV. Yeah, you're doing the reverse conversion. I'm going in the other direction. So I'm going from a number into Roman numerals, not from Roman numerals to a number. Yeah, and I'm actually, I don't know if Alex Teeb and John Enriquez are watching, but I think I figure out what they're talking about. So you go through the lookup and you find the largest possible number that the remainder of the number goes into, and you use that. Then you subtract it, and then you find the largest possible number. That is definitely a better algorithm. Yeah, and so that way we can only have the main ones. We don't have to put like an entire one. Okay, so we don't need all of this. We only need the single letters. So like, what are the single possible things that we can do with Roman numerals? And this is very similar to like creating change using specific coins. Because you grab the largest possible one and then you add the ones of the next. Yeah, so that should be easy enough. Do I have all possible? IVXLCDM. IVXLCDM. Cool. So the example that they sent in the chat. Whoa. Let's comment this out. So you subtract the largest possible remainder from the number. So let's say we're given 1990. And we go and we find the largest possible number that this is greater than. And then John is saying you need to insert the specific IV and IX case somewhere after that. Yeah, so if it wasn't in there, then we have to find the specific ones. So I guess our lookup table should have the double letter combination. Yeah. I think we should do 1 and 2 letter combinations, and then everything else will use our lookup table. I mean, yeah, everything else will have a certain number of iteration. Yeah, so the special cases. So not just these cases. We need the cases where it's 2 letters as well. Correct me if I'm wrong, and then from there we can go. So we do need 4, which is going to be what is 4? IV. Cool. And then we do need 9, which is IX. And then we do need 40, which is XL. And then we do need, and I guess that makes sense because if you have 80, the highest possible one would be L. Then you need 30, so it would be LXX or XXL. I don't know. It's making sense. So we have 50, and then we have 90. And then we have 400. And then we have 600 DC, and then 900. Okay, this is our lookup table. All right, I'll see you later, Wemo. Thanks for the good luck. Okay, now we just need to make change. So we find the largest possible number, append that, subtract that number from our existing number, do it again, keep on doing it. All right, I'm ready. I'm got some tea. Let's do this. Okay, so we need to enumerate the input. So we can do like the, I'm gonna call it numbers. Let's say lookups. Just call it keys. Is going to be object.keys with the lookup. Why is this complaining? This can be a const because we're not reassigning it. Lookup is not defined. Oh, capital U. Okay. So we're creating an array that has all of the possible numbers in it. Now we want to iterate over that array and find the largest possible number that our number will fit into. So let's say, and actually we want to do it in reverse. Yeah. So let's just create a for loop. Let I equal keys.length -1 while I is less than or equal to 0. So we're going in reverse. And then I minus. And we'll say if our number that we have right now is greater than keys at I, then that means that we want this character. So right now, let's say number is 1990. Is 1990 greater than 1000? Yes, it is. So we want this im. So we need a place to store Roman. We'll set that equal to a string. And then we'll say Roman plus equal lookup no, at keys at I. So we're going to grab that specific character, add it onto Roman. And I believe, are we going in this direction? Yeah, so I should be able to just append it, because if I put m and then append cm, cool. So append that to Roman, make that a let. And then subtract this number, the current key. Let's throw this in a variable. If number is greater than Roman letter, then we'll do the lookup at the Roman letter. Cool. And then we need to say our number subtract the current value. So then that will give us what we need to do the lookup next. Cool. And we need to do this over and over again until a number is 0. So we'll do while number is greater than 0, do this. Okay. I'm feeling okay about this. It was a really rough start getting here, but I think this will work because so let's say the case where we have 1990 and we want to end up with mccm. Okay, so right now the number is 1990. We're going to go in here and we're going to happen upon 1000. And 1990 is greater than that, so we're going to grab an m. So we put an m onto Roman. Cool. We subtract that. Now we have 1990. We're going to look. 1990 is greater than 900, so we have a cm. We're going to add that on there. We subtract that. We get 90. we want to do less than or equal to because now that we have now that we have 90, is it less than or equal to XC? Yes, it is. So then we'll add XC to it. Okay, this is the winner. Let's see what we got. Node Roman numerals. Do I have an infinite loop? I think I do. Let's see real quick. So we're iterating in reverse. If number is greater than or equal to this, then Roman will be appending that letter inside of our lookup, and we'll subtract that number from number. Greater than or equal to, no. Let's take a quick break. I might actually run this code through the debugger just to see where my infinite loop is. Cool. Well, let's try this with the case of, I guess 4 is in there. Try it with 1,000. It should be just greater than, because when it's 0, we want to break out of this while loop. Oh. We need to break right here. Because we just appended a number, we're going to break out of the for loop. Because otherwise it kept appending more and more. I think. Oh no, let's debug this thing. Anybody watching at home, if you see the issue with my code, let me know. But I'm going to run this through the node debugger so we can just like step through each line. So we'll do node -- inspect break. Yeah, so this will automatically break right when you run into our code. We will see what is going wrong. Okay, so the debugger is listening. I should be able to find it in Chrome. Inspect. Okay, so we are here. Let's set a breakpoint right here. And we're going to try this first. We'll try it with 1990. So when it gets here, right now in our scope, number is 1. Can we change? Yeah, let's change this to 9. We're going to test this with 1990. Make sure that it works. Okay. So first we create our keys, which are all the possible letters that we could throw in there. Then we make sure that number is greater than 0. Cool. So we're going to iterate over the keys until we find a number that is that our current number is greater than. So we're going to do it in reverse. So we'll start at, wait. Oh! Ha! I found why. This needs to be greater than or equal to 0 because we're not iterating, we're iterating down. Oh, that was our infinite loop. Okay, good thing I brought out the debugger. So because we're iterating in reverse, while I is greater than or equal to 0, decrement I, then we'll have our Roman numeral. Okay. No, don't do that. Yeah, thanks Alex Tube. He found it in there too. Yeah, I can't believe I did that. Always step through your solution before you assume that it works, especially when you're doing something like a reverse for loop, because we're so accustomed to like doing a greater than or equal to, or sorry, a less than or equal to. But that did it. I'm happy. Thanks so much, Alex Tube, for the help. Cool. I'm glad we figured this out. It was a rough start. It was a very rough start, but we made it there. I'm curious, could we potentially turn this into a reduce? because we're reducing. I guess not really, because we have side effects, like we're actually overriding the number with a new value. Cool. But those of you that have never used the inspector before, I'm gonna run through my solution one more time in the inspector just so you can see how that thing works. So if you have Node installed on your system, you can do -- inspect break. What this says is inspect the code and then just immediately stop before running anything, and then you give it a file name. And then that you can go into Chrome inspect, and it should show up as a remote target. You will have to install an extension for this, but if you look for like node inspect on the Chrome store, you can find it. And then if you click inspect, we're actually inside of our code and we can run like one step at a time. Cool. So first, we're trying it with the number 1. So we're going to go into our while loop. Is 1, we can see over here in our scope table, is 1 greater than 0? Yes, it is. So we go in. Now we're going to iterate over all of our keys. Now we grab the very last key, because right now I is 13, so we're going to go all the way to the end of that lookup table. And so our current Roman letter is 1000. And so this is the other cool thing about the Chrome inspector. When you're using block scope variables like let, it'll actually tell you like this is block scope. And these are the values that are inside of it. So Roman letter is now currently 1000. And then we're going to see, is number greater than or equal to 1000? No, it's not. So basically, this for loop is just going to keep going all the way till it gets to the end to the beginning of the array where 1 is equal to 1, because right now we're testing it with 1. Now, finally, Roman letter is 1, and so our Roman numeral will append, if we look at what Roman is, we'll append I, and then we'll subtract 1 from the existing number. That gives us 0. So when we do our comparison, we break out, and now we return just the letter I. Cool. I do want to see this. Let's break whenever we try 1990, because this is the one that I was trying here. So run all of my code till I get to this line. Now run my code till I get to that line. So now we're trying it with the number 1990. So we'll say keys are all of the possible values that we want to look up. Is 1990 greater than 0? Yes, it is. And so now we're going to iterate in reverse. And so our first one is 1000. Is 1990 greater than 1000? Yes, it is. So we take our Roman, which is currently nothing, and append the character for 1000. So we're going to append an im onto it. And then we subtract 1000 from 1990. So right now it's 1990. After this, it will become 990. We bust out of this for loop, and then we check, is our number greater than 0? Yes, it is. So we keep doing what we're doing. We grab all of our keys again. Is 990 greater than 1000? Currently, our Roman letter is 1000. It's not. So we'll go back again to the next one. Now we're at 900. Is 990 greater than 900? Yes, it is. So we'll say Roman plus equals the value for 900. Cool. We'll subtract 900, which will end up with 90. Bust out of the for loop. Is 90 greater than 100? Yes, it is. And at this point in time, Roman is MCM. And now that we have 90, we already know that it's in the lookup table. So when we iterate over everything, we're going to reach when Roman letter is equal to 90. We'll append XC, subtract 90 from the number, which brings the number down to 0. So when this check happens, it's done, it breaks out, and we have our Roman numeral. Whew. That was fun. So AlexTube is saying that I can make this solution a bit more effective because you don't need to restart searching from the largest number. Like pop the last number from the array and then check and pop that. That makes sense though, because if we've already grabbed the largest possible number, Actually, would that work for 2007 though? So that works for 1990 because after that there's no number greater than that. But that wouldn't work for 2007 because I need to come across im twice so that I have im. Does that make sense, Alex Tube? I think like that case specifically works if the ones digit is 1, but if the ones digit is anything more than that, then we actually will need to loop across the array again. Just to see, let's try this one more time, but with 2000. So while number is greater than 0, it currently is. We're going to iterate. And so is 2007 greater than 1000? Yes, it is. So we append an im and then break out. And so because we broke out, we need our keys to still have 1000 in it, because now we need to look up the number for 1000 again. Let's see. So right now Roman is im, and I can look that up. Add im, go back around. In this case, it's not going to find... Wait, what is... Oh, now the number is 7. Oh, wow. So that was easy enough. It's going to find a 5. So, Alex Chu was saying that would work. You remember the largest number, and then you subtract while that number is greater than it, then you pop it from the array. Oh, this would actually reduce the number of iteration too, because we wouldn't have to go back around. I like it. Let's do that, and then I'll submit my solution. So right in here, we'll say if number is greater than or equal to Roman letter, add it. And let's just do a while number is greater than or equal to Roman letter. We'll do this. Then we'll pop off the last number because we don't need it anymore. So we'll say keys.pop. So it'll pop it off, and then we'll do it again. I think that should work. Let's try it. True. Cool. Thanks for the tip, Alex Tube. Yeah, because basically if we do it once and it's still greater than, then we want to use more ims, right? And same thing with like if there's multiple, I guess would there be multiple cms? I don't know. Let's try it on codewords. Here we go. Sample tests. Thank you, Alex Tube. And also, who is the other person helping me out? John Enriquez. You guys rock. Attempt. Drum roll. Submit final. Drum roll. It's happening. More drum roll. It's really slow. Oh, there we go. Sweet. Fantastic. This was probably one of the ones I spent the most time on this stream. But I appreciate you for sticking by, for helping me out. We did a lot on this stream. Some pretty hard ones too. I'm going to push all these up to GitHub, and you can check them out. Let's look at what their solutions were. So they did a similar thing, but instead of doing like object.keys, they did a for in loop. So it would give you the keys, and then you can pull out the value from that. Makes sense? Pijo, thank you. We made it through it. I feel like it's one of those like super like nerve-wracking interviews where you can't think straight and you just gotta, I don't know, you just gotta power through it. Eventually, like it clicked and I was like, oh yeah, I was about to write out like just the largest lookup statement. Oh, cool, they did it with a reduce. So they have their lookup table, but they have this property called threshold, and then so and then they're just moving like one at a time. So while the number is greater than the threshold, add the current character to it and then move on. I like that solution a lot. That's really cool because they're accumulating. So with the reduce, you're reducing it to a single value. So they're reducing this array of lookups to the Roman numeral value. That's slick. Cool. Similar idea, but instead of storing it in an object, they stored it in two arrays. Awesome. Okay, we did it. Okay. Yeah, that's pretty much it. Thanks everyone so much for tuning in live. Um, some housekeeping. If you check out my YouTube channel, tomorrow morning I'm just going to be doing morning tea with CJ. That's where I browse the web, talk about the latest tech and JavaScript news, and sometimes if there's like a new library out or something like that, I'll try to make something with it. But a special show on Sunday, Brooks from Brooks Builds is going to be pairing with me, and we're going to build a breakout game or a brick breaker game with P5JS. So be sure to tune in for that. I've myself have never actually written anything with P5JS. I've watched a lot of Coding Train and watched Dan Schiffman do it. Um, and I mean, I get it. I can watch it and see it happen, but I've never literally done it myself, so that'll be fun. And yeah, all of these solutions that I created today, I'll push up to Code Katas, and you can take a look at those. For my full streaming schedule, you can check out coding.garden. I am going to do a can you see that? I am going to do a morning tea stream tomorrow, but I am going to skip the afternoon stream tomorrow. But I will replace that with either a Friday or a Saturday stream. So if you look for my channel and you have notifications turned on, you'll see when that scheduled stream pops up. Briggs says, amazing as always. Thanks so much. I feel like I really struggled through that last one. I could not have done it without the chat. I appreciate you guys. And Pijo's asking, where do we submit stream ideas? Thanks for asking. So there's a website, poll.coding.garden. And you'll have to log in with GitHub. That's just so people don't vote multiple times. But I only get your email. I'm not asking for any other privileges. So once you log in with Google, you can add suggestions or vote on existing suggestions. So there's a few things in there. I think pretty soon I'll probably do something with GraphQL. I haven't done that on the channel yet. And also something with Redux and React. Yeah, and this would be fun too. I actually haven't worked with Nuxt.js, so Nuxt is server-side rendered Vue.js applications, which is similar to, I think, Next, which is for React. Maybe it has a different name. But and really, you don't have to do much extra work. You can still build your Vue.js application, but if you write it with this, it creates it as like a hydrated server-side rendered app, which is pretty sweet. But yeah, if you want to submit ideas, you can click suggest a video, add that in there, and then you can click the heart to vote on other suggestions. All right, I think that's it. Thanks everyone for tuning in and checking it out. Is figuring out deckgl with Vue too complex? I don't know what deckgl is, but honestly, submit anything. Like I always open to new ideas, always open to like even like learn things on the stream. Deckgl, I've never heard of it. WebGL powered data visualization. Oh, cool. So like I have heard of Three.js, which is like a library on top of WebGL, but this looks awesome. Let's see some examples. So it's not only is it because Three.js is very somewhat low level, so you have like vertices and shapes and things like that. This looks like it comes built in with like various visualization things. Enhance, zoom in. Very cool. 3D indoor scan. That would be another thing. I don't have anything on the list for it, but I'd love to do some live coding with like virtual reality or something like that. Whoa! So this is like a what's this called? You have a um, not a scatter plot, but basically like they scanned this place in 3D with and then grabbed all of these points in 3D, and now they're rendering it. Wow, that's awesome. This would be fun to explore. There might be a like a Vue.js wrapper with it, so that'd be cool. Pijo says they use it to show real time locations in America with heat maps. It looks awesome. That'd be great too. All right, that's all I have for you. Thanks so much, everyone, for tuning in. Thanks for all your help, everyone that tuned in and messaged in the chat. I do this every Wednesday at 8:20 p.m. Mountain Time, so be sure to tune in next week. And I think that's it. Have a wonderful morning, afternoon, night, wherever you are in the world. I'll see you next time. And here is this.